count us down, Michael? Okay. Hey, guys. Welcome, everybody. We are live. How exciting. My name is Mike O'Toole. I'm the science coordinator at St. Vrain Valley Schools in Colorado. So excited to be here with you because two of my favorite things are learning about science and sharks. And today we get a little bit of both. Hopefully everybody can hear me okay. What we have, let me go through the basics with you. We're using Adobe Connect, a webinar system, and our show today is about an hour long. We're going to be going live and seeing some amazing videos, hearing from researchers and scientists in the field, and at the end, the last 20 minutes or so, you are going to have opportunities to ask questions. And we're going to use the chat bar to do that. It's going to disappear during the presentation so we can maximize the video size. But at the end, we'll be able to answer quite a few questions, and hopefully we'll get to everybody's, okay? So before we start, let's get a shout out. If you could, in the chat bar down there, in the chat bar, go ahead and type in where you're listening from. Okay, so here we go. Let's see. We've got Dodge City, Kansas. We've got Longmont, Colorado, Baltimore, Maryland, Westview, Colorado. Geez, it's going so fast. Denver, Colorado. We've got Ontario, Canada. Erie, Santa Barbara, California. Junction City, Kansas. Hygiene, Colorado. Hygiene Elementary. Got Maryland in the house. Fort Raleigh, Kansas. Lakeside, California. Quite a few from Kansas. California, Wisconsin. Oslo, Norway. Louisiana, Michigan. Some more from California. Well, wonderful. That's great. And we're going to use this same chat window to ask questions near the end. Now, it's exciting. We have schools, teachers, and students tuning in from all over the country, all over the world, really. And one thing we share in common, a lot of us are not near the oceans. So today's going to be a pretty special day and a pretty special webinar because we're going to get transported there to the oceans. Today we're going to be working with two researchers who, they have an amazing job. Dr. Mikki McComb-Kobza from Ocean First Institute and Dr. Chris Lowe from the Cal State Long Beach Shark Lab. So guys, how are you doing today?
Pretty good.
We're good.
Well, good. I know you guys have an amazing job, and we've got a lot of students from all over the world excited to chat with you guys and hear a little bit about what you've been up to the last couple weeks. So I'll turn it over to you, and should be a good show.
All right. Well, welcome. Welcome, everyone. We're so excited to have you join us. My name is Dr. Mikki McComb-Kobza. I'm the director of Ocean First Institute, and I'm so happy that I'm here today in the Shark Lab, which is at Cal State Long Beach. That's where we are. And the Shark Lab is run by my good friend, Dr. Chris Lowe. So we are here today to talk about our passion. Chris and I both love sharks very much, and both of us really have spent our lives trying to understand sharks a little bit better. And we have many tools that we use as scientists to try to discover the secrets, to unlock the mysteries of the sharks. We want to know where they go. We want to know how long they live. We want to know how they find each other underwater. All of these questions have really captured my attention and Chris's research over the last 20 years or more. And we want to share some of that with you today. And so, I think we became scientists because we're curious. And really, that's all it is just trying to understand animals and to understand these very interesting creatures that we just don't know that much about. And so what I'd like to do today is talk a little bit to you about a trip I just took. I just got back a few days ago from Isla Guadalupe, Mexico. And I was there to be able to observe and go diving with great white sharks. So I'm going to tell you a little bit about that trip, what I learned along the way, and then we'll come back to Dr. Chris Lowe, who will tell you about his research here in California and how he uses cutting-edge technology to be able to unlock those secrets about the great white shark. So I'm going to go ahead and get started, but before I do, I just want to take one moment to thank a very close friend of mine who's here with us today. His name is Dan Stetson, and I would like to have Dan come over for one moment. Dan is someone who has had a vision and a passion to share the story of the great white shark with students all over the world. And I'm very proud today to be here with Dan with his invitation. I just want to thank you so much for making this come true.
My pleasure.
I'm so grateful. And we were able to get funding from the Nicholas Endowment to make all of this happen, so I'm very grateful for that. So thank you, Dan. I'd also like to thank Andrea Stockert, who is our filmmaker and our producer, who came on this expedition with me and made incredible things happen, and I'll show you what some of those incredible things are in just a moment. I'd like to thank the Historical Diving Society, the Academy of Underwater Arts and Sciences, OTS, for letting us use some really neat masks underwater. I'd also like to thank anybody joining us from the Microsoft Educator Network and our partner Skype in the Classroom. I'd also like to thank Axel, Patty, and Craig at the St. Vrain Innovation Center for helping me build some of my scientific equipment. And I'd also like to give a very warm welcome to Renee Collier, to the parents, the teachers, and the students of Hygiene Elementary, and also to Nicholas Kobza. So thank you all so much for joining us. We're going to go ahead and get started. So I'm going to take you with me on my journey that I just took a few days ago to be with great white sharks. So again, I was just mentioning that I went to Isla Guadalupe, Mexico. This is an 18-hour boat ride off the coast of Mexico. Here I am riding on the boat, looking out onto the island, which is home to many elephant seals. We arrived in the evening, and the crew was able to put the cages in the water that we would be diving in the early morning. So in the morning, the captain took the cages, got those in the water, cleared the deck so that we could bring out all of our dive equipment and go ahead and get into the water with those great white sharks. And so if you can see the next video, I want to show you what it's like to go down in a cage with these magnificent animals. So what you can see here is I'm wearing a full face mask, and I jumped into the cage, and I'm behind the boat, and I'm actually able to talk live, and we beamed to Colorado, to New York, and to Chicago, and we were able to show students the sharks swimming in the water, and I was able to narrate and talk about the sharks, their external anatomy, a little bit about their biology. And we did this live in the middle of the ocean through satellite technology. So it was an incredible success for us, and we hope to continue to be able to beam and broadcast from these remote areas to bring the sharks to students, to let them see what those sharks are really like. All right, so one of the things that we did on the trip, and I'd like to show you again what it looks like to be next to the great white shark. So here you see what it's like to be in the water with them. And as this shark is swimming by, you can see it's got a large fin on top of its body. That's its dorsal fin, which it uses to prevent rolling. It's got a second dorsal fin on its back. And then as it swims around here, you'll be able to see it's got two fins on the side called its pectoral fins, which it uses to steer and to maneuver. And what you're looking at here is one very large shark, and this is a female. Females are typically larger than the male sharks, and that's an important thing for us to distinguish. So this is a female shark, and I can tell the difference between a female and a male by looking near the pelvic fins. And so as this male shark goes by, you can see those two appendages sticking out there. Those are called claspers, and that tells us that we're looking at a male shark. So that's how we tell the difference between males and females. And as the shark is swimming by, you can see it's got gray on top and white on the bottom. That's counter shading. This is to help the shark blend into its environment. These white sharks are ambush predators, and so they use the element of surprise and they conceal themselves. And this fin here on the back is called the caudal fin of the shark, and that is used to propel the shark through the water, and you can see that that's happening right here. All right, and so one of the other things that is important to know is that sharks have a suite of sensory systems, even more sensory systems than we have, and they're using these sensory systems all the time. So sharks have excellent eyesight, so they have large eyes that rival ours in their function. They have the ability to smell through their olfactory system. So you can see here, that's the nares or the nostril of the shark in the front, well-developed eye. And then those little red circles around the shark's head are the ampullae of Lorenzini. So sharks have the ability to detect weak electric fields underwater. Every living thing gives off a weak electric field, and sharks have evolved to detect it. So this is a fantastic sense that the sharks use close range in order to detect their prey, and possibly even used in navigation. These are, again, questions we don't know the answers to, and we are trying to understand. Okay, so continuing on, one of the things that we did when we were in Guadalupe Island was to try to identify individual sharks. And so this is a goal because sharks are moving in from dive to dive, they're moving in from season to season, and they're moving in from year to year. And so it's important for us to try to understand these movements. And so one of the ways that we identify individual sharks is by taking photographs. We take photographs of both sides of the shark, and then we look at specific regions of the shark, and we use those almost like fingerprints that help us determine individuals. And so one of the regions that we look at with the shark is around their gills. And so near the bottom of the gills, there are sometimes dots or patterns that help us identify the shark. Near their pelvic fin, sometimes there's connections between the gray and the pelvic fin of the shark. Sometimes there's dots. And then on the tail fin or the caudal fin, again, there might be markings that are very unique. Also, the dorsal fin sometimes has injuries or nicks or mutilations. Sometimes sharks will lose part of their fin from damage. Those are things that we can use to help identify individuals. We don't look for scrapes or markings. When females and males mate, sometimes males will bite females and we'll see marks, but those heal over time, and so those are not good things to use when we're trying to visually identify the sharks. All right, so one of the other goals that I had when I was in Isla Guadalupe was to actually measure the sharks. So not only is it important to understand the individuals and identify them, but it's also important to collect data, to try to find out how long these sharks are, perhaps. And we can start to identify the individual sharks and take measurements. And what that does is that allows us to understand if the sharks are growing, how much are they growing, if we can get good data on their length. So in Colorado, I was able to go to the St. Vrain Innovation Center and work with high school students who helped design and create a laser measuring device for me. So how exciting that these students, Marco and Alex, helped me design and create a shark laser measuring device. And so what they did is they created 2 laser lights, set them 50 centimeters apart, and then we put a GoPro camera in between. And what we were trying to do is to shine those 2 laser lights, green in wavelength, in color, on the side of the shark as it swam by. And so what I would do is go into the cage and shine those lights onto the side of the shark as it swam by. And so if you can see in just 1 second, the video of me underwater in the cage. So I took my device down with me, and what I'm trying to do is to get a shot of the shark on its side, about 90 degrees perpendicular to me, so that I don't have any errors. And what you'll see is the shark coming up right here, And you can see just barely the two dots on the side of the shark there. And what that is doing is it helps me when I can go back into the lab, look at that photograph, and then actually use it to estimate the size of the shark. So a neat, inexpensive way to try to get more information about these animals that we're just trying to understand. So this is a large female. Her name is Scarbird. Some of the sharks actually have names. And so we're measuring her as she swims by the cage repeatedly, which was very exciting. We were able to measure, I think, 9 different sharks on our trip, which is more than I thought I would get. So I'm very happy about that. One of the other things I did on the trip was record some basic observations. What were the sharks doing underwater? How are they interacting with each other? At one point, we saw a shark shaking its head and making some territoriality or maybe some aggressive postures. These are animals that are there for food, and they're competing with each other. So we were marking down some of the behaviors that we were seeing the sharks exhibit. So we were taking note of all of that. And again, we're trying to understand where these sharks are reproducing. We're trying to understand where they're having their babies, their pups. These are questions that we still don't have clear answers on, even though these are iconic animals we all know. We still don't have all of the answers yet. And so really we're using as many tools as possible to try to address these questions and to try to figure these things out. And so Dr. Chris Lowe uses some very cutting-edge technology to address many of these questions of movement and biology with all of his students, and he's been doing it for well over 30 years. So I'm very excited to pass over to Dr. Lowe, and he's going to talk to you about his research and why it's so important.
So one of the questions we always want to know is, why do sharks do what they do? So whether we're talking about an adult white shark or a baby white shark, why do they do what they do? And that's really hard because we can't talk to them. So we have to be able to get information about their behavior using other tools that help us kind of piece together why they're doing what they're doing. So 20 years ago, we just didn't have those tools. So we could kind of see sharks along the coast. We'd see them doing different things. They'd be feeding on maybe a sea lion or something like that. But after that, we didn't know where they went, and we didn't know why they left or when they came back and why they would come back. So we had to develop new tools for answering those questions. So in the lab that I work in the shark lab, we have been, for many, many years, using a technology called acoustic telemetry. So this is a transmitter that we can put on a shark, and this produces a sound wave that travels through the water that the shark can't hear and we can't hear, but we have technology that enables us to hear the tag. Now, in the early days when we built these transmitters, I would have to make them myself. Then we would go out, and they're really big and clunky, and we'd put them on a shark, and then we would follow the shark by being up in a boat, and we would track the ping that the transmitter would produce. And we'd be out in the boat for days at a time. Now, the problem was we knew where the shark went. We just didn't know why it went there. So we needed a way of looking at more of what was happening around the shark. The other problem with this technique is you get tired. You're in the boat for days and days at a time. You get exhausted, and you can only track one animal at a time. So as the technology developed, we actually began to be able to program these transmitters to have a unique ID code. So each transmitter is unique. Then what we would do is we could have underwater acoustic listening stations that we can put out all around the coast. Now, anytime a shark carrying a tag comes within 500 meters of one of these receivers, the receiver logs the ID number, the time, and the date that shark came by. So we can kind of use this like spy technology to figure out where the sharks are going. So this technology greatly expanded our ability to figure out where sharks are going and when they're going there. But it still didn't answer all the questions. So we didn't know what was happening on and around the shark at the time that it's doing this. So the other technology we use are called satellite transmitters. So this transmitter uses radio waves. Now, radio waves don't really penetrate through seawater. So the only way this satellite radio transmitter can work is the antenna has to be at the surface in air. So what we can do is we can dart this onto the shark. The shark carries this. This is called a pop-off archival satellite transmitter. It has a light sensor, a temperature sensor, and a depth sensor. And we can program this to record those 5 times a minute. So the shark carries this on its back like an earring, it's hanging off its back, kind of cruising along, and at a pre-described time and date, this is programmed to pop off the shark, float to the surface, and then this thing bobs in the water, and then it transmits all the data to a satellite. The cool thing is, then it sends me an email while I'm at my desk saying shark number 205 just popped off, and then it downloads all the data. So I get to see the temperature and the depth of the water that the shark moved through. Now, because this transmitter is measuring light, if we know the time of day and we know how long the day is, we can actually estimate the latitude and longitude that the shark is at as it's moving through the water. So unfortunately, this technology gives us really accurate information about the depth and the temperature the water is moving through, but it doesn't really give us an accurate position of where the shark is. So another technique we use are what we call spot tags. So a spot tag is designed to bolt onto the shark's dorsal fin, and then every time the shark's fin breaks the surface, here's the antenna, it sends a radio signal up to the satellite. The satellite are then able to use what we call a Doppler shift, like an echo of the sound, to estimate a latitude and longitude. So we get a position. So every time the shark breaks the surface, it transmits, but as soon as it goes underwater, it stops, because radio waves cannot be transmitted through seawater. So this time we get a position. Now, but remember, sharks aren't marine mammals. They don't have to come to the surface to breathe. So when we started putting these on little sharks, we thought, well, how much data will we get? How much time do they spend at the surface? So it wasn't until we actually started putting this technology on these sharks that we figured out these little sharks spend quite a bit of time at the surface. My colleagues have been tagging adult white sharks with this technology, and based on that, we found that adult white sharks swim all throughout the Atlantic and all along the eastern Pacific. So this technology has greatly changed our idea of what kind of shark a white shark is. So in order to get even more accurate information, sometimes we want to know every single body movement the shark's making, and we want to see what the shark sees. So to do that, we've made these special backpacks for sharks. So this is designed to clamp onto the shark's dorsal fin, and we call this a smart tag. So the smart tag has a 3D accelerometer, it's got a pressure sensor and a depth sensor, it's got an acoustic transmitter on it so that we can follow the shark, it's got a video logger so we can record up to 12 hours of video that we can see what the shark sees, and then it's got a radio transmitter. So this gets clamped onto the shark's dorsal fin. Mikki, can you help me?
Yes.
So just give me your hand like a dorsal fin. So this would clamp onto the dorsal fin, and then this little device back here is called a magnesium link. So magnesium with other metals will dissolve away at predictable amounts of time. So we can literally zip tie this onto the shark's fin. The magnesium dissolves after about 24 hours. This thing pops off, floats to the surface, and then using a radio antenna, we can recover this. So then we can download and we can see every single tail beat the shark made, whether it went up or down, left or right. We get to see what the shark is seeing, so we know why it turned right, why it turned left. And the other technology we can use is, instead of us being out in a boat following the shark around, we've actually made autonomous underwater tracking robots. These are robots that we program to follow the shark with a smart tag. It knows exactly where the shark is. And the cool thing is, we've programmed the robot to be smart. Because the robot has a propeller, it's making sound, we know the sharks can hear it. So if the shark starts swimming towards the robot because it's curious, the robot's programmed to swim away. And even while it's moving away, it still knows exactly where the shark is. So when the shark gets bored and says, I don't know what that was, but I'm tired of that, turns around, starts going the other way, the robot turns and starts to follow the shark again. So the cool thing is when we were programming the robot, we actually had to use what we learned about shark behavior to program the robot. We want the robot to mimic shark behavior. So what it starts to do is become a copycat. So whatever the shark is doing, we want the robot to do, so that it's mimicking exactly what the shark's doing, and we can gather all that data. So by using all this technology, we can better answer not just why the shark went from there to there, but what is it doing? Who's it hanging out with? Was it detecting schools of prey? Why was it there? So this technology has been really great, but for sharks that live in shallow water, we use another technology. And this is standard off-the-shelf drone technology. So by using aerial drones, we can basically fly this over shallow water, and we can see what the sharks are doing from the air. And this technology is great because it's given us a completely different perspective of sharks that exhibit schooling behavior.
Right.
Why do they hang out in a school? Are they really wanting to be next to each other, or are they being constrained by environmental conditions? So by using this technology, we've been able to expand that. Now, the cool thing is, I'm just a biologist. I love playing with technology. I love the tools that come from it. But you know what? I'm not an engineer, and I'm certainly not a computer scientist. So this gives me great opportunity to work with other scientists, like engineers and computer scientists, where we get to take lots of the cool data that we get. But I need help learning how to crunch those data. So by working with the computer scientists, they help us develop tools so that we can visualize what we're seeing to make more sense of it. In addition, by working with engineers, we can say we need a drone that will do something that no other commercial drone will do. We want it to have 2 cameras, and we want it to be able to use that, just like Mikki's parallel lasers, to measure the size of the shark, regardless of how high the drone is in the air and how deep the shark may be in the water. So by using parallel images, we can measure the distance between the 2 cameras and use that as a calibration to estimate size. In addition, just like facial recognition software, we can develop software that will tell us what species of shark it is based on their dorsal outline or their patterns on their body. So there are tons of opportunities for people who are interested in biology but like playing with technology. So there are lots of opportunities for what I call hybrid students. Those are students that have interest in engineering, biology, computer science, math, because this is the wave of the future. This is the technology we'll be using in the future to answer questions that we couldn't even believe we could answer 20 years ago.
And this device, that's your AUV?
Yes, that's our AUV. That's our robot.
Okay, and that's what's following the sharks underwater.
Yep. So it has 2 hydrophones, and each hydrophone is measuring how long it takes the sound from the transmitter on the shark to reach each hydrophone. So by working with a roboticist and computer scientist at Harvey Mudd, we've been able to use this to autonomously track sharks as they move around doing their natural thing. So here are students writing the software to actually program the robot.
That's fantastic. And inside of the shark, they have tags. So the AUV is following a tagged shark that has a tag.
So in some cases, the tag is on the inside of the shark.
Mm-hmm.
We surgically implant it inside the body. In some cases, we put it on the outside, kind of like an earring. And in other cases, we use our backpacks.
Okay.
So the robot can track any transmitter, no matter where it's placed on the shark.
That's fantastic. And so I'm wondering, too, you have a contraption over here, some GoPro cameras, and maybe you can tell me a little bit about what that does.
So obviously, we can't tag every shark, but we want to be able to figure out who's around a beach if we can't get close to them. So we use this technology, which we call RUVS, R-U-V-S, Remote Underwater Video Systems. So it's basically 2 GoPros on a stick. Now, we've been studying baby white sharks in Southern California. This is their nursery. So females come to give birth here, and these babies will come in close to shore. But they're very shy. So from the time they're born, they're on their own. They have to learn how to feed on their own, and they get no instruction or help from mom. So they're afraid of everything. Even though they're 5 feet long at birth, they're scared of everything. So if we were to jump in the water and we wanted to film the sharks, they wouldn't come close. Water's a little murky. So what we do is by putting the GoPros out, we stick them in the sand, we just turn them on and walk away. So what happens is the sharks are actually curious of the cameras, and they'll swim right up to the cameras. So when they do this, we can actually use the same technique that Mikki was talking about. We can identify individuals based on their facial marks. So this is some footage of some baby white sharks. And remember, these sharks, even though they look huge, are only 5 feet long. They're just little babies. And you can see how they have all those distinct markings around the gills and on their tail. And sometimes they even have chunks taken out.
Right.
So we can use those, kind of like facial features, to recognize individuals. But we have to get video footage of both sides. So what I have is when we come back, we go through hours and hours of video. And then my undergrads, like Sarah, will go through and look at all the video. And if we find a shark, we'll take a frame, and Sarah will hand draw all the unique markings.
Right.
So we're building libraries of these sharks.
And how many sharks do you have in your library?
So far,
We have 6 sharks that we've seen up close that I can draw, and only 2 that I've seen from both sides that I know that that's one shark.
So it's very challenging.
Not easy. The shark basically has to do a nice little loop in front of the camera for me.
And then go around the
in
other
both
way.
directions. Yeah. So, but by combining all these tools together, we can better answer questions like how do baby white sharks use Southern California beaches
Right.
as a nursery?
Right.
And what makes certain beaches so special to them? Is it water temperature? Is there lots of stingrays for them to eat on the bottom? And remember, a lot of these beaches, there are a lot of people there.
Right.
There are people surfing and swimming and kids playing. And for years this has been going on. And it looks like as long as we mind our business, those baby sharks mind theirs too.
And do does some of your research show that white sharks are increasing in California? Can you tell us a little bit about what you found through your research?
So, I've been studying sharks in California for almost 30 years now. And when I first moved here back in the late 80s, I never heard of people catching white sharks off Southern California. Or, of course, it would be really rare to see a baby white shark. And in the last 10 years, those numbers have just been going up and up and up. And the other really interesting was we just came out of a strong El Nino. And El Nino causes our surface waters to get very warm. And one of the things that we found over the last 8 years of tagging these baby white sharks with all that technology is in the past, when we got to winter, like December and January, and our water temperatures started to drop, when we got water temperatures below 60 degrees, all those baby white sharks quickly migrated south to Baja.
Okay.
And they spent their winters in Baja, where the winter temperature was equivalent to our summer temperature.
I see.
And then what's really cool is some of those sharks the following spring came back to Southern California. But during the El Nino, our waters never really got that cold. We never had winter. And the cool thing was none of the sharks left.
They stayed.
They stayed. So what that tells us is that water temperature is an important factor that influences where they migrate. But the other thing it tells us is there had to be sufficient food for them to eat during the winter to survive. So that's a good sign. That means not only is the population going up because there's more babies, but Southern California actually is a good nursery fishery. They're protected. Fishermen aren't allowed to catch them. If they catch them accidentally, they have to let them go. And we know that baby white sharks are actually pretty hardy. So even if they're caught in a gill net and they're released, they can survive.
And speaking of little baby great white sharks, do we have a jaw here that maybe we can take a look at that shows us the difference?
Yeah. So here we have a baby white shark. So this one is less than 5 feet long, and you can see its teeth are very sharp and pointy, almost look like a mako shark's teeth. But their upper teeth are actually more triangular and serrated, like you